Good day everyone. So today we're going to talk about the optimization problems. So the goal with these types of problems is that you're trying to optimize something. We're trying to find the optimal conditions to get better results. So therefore, in order for us to solve with these types of problems, you need to be able to find the maximum and the minimum value of a function. So today, we're going to show you some examples on how to deal with optimization problems to be shared or explained to you by my group mates.
Find the dimension of the rectangle with a perimeter of 2000 meters so that the area of the rectangle is a maximum. X equals to length and xy equal to width. 2000 equals 2x plus 2y, it is a constraint, and a equals to xy, it is an objective. Solve for the y in terms of x. 2000 equals 2x plus 2y over 2y over 2 cancelled equals to negative 2x plus 2000 over 2. Equation 1 is y equals to negative x plus 1000. Substitute equation 1 to objective functions. A equals to xy equals to x open parenthesis negative x plus 1000 close parenthesis equals a equals x squared plus 1000x. Find the derivative of v. A equals to negative x squared plus 1000x equals a equals 2x plus 1000. Find x. A equals to negative 2x plus 1000 over 0 equals negative 2x plus 1000. Cancel 2x over 2 and equals to 1000 over 2 and x is 500. That's it.
Find y. Y equals negative x plus 1000. And the value of negative x is negative 500. So it will be y equals negative 500 plus 1000. Since 500 is negative, instead of adding it, we'll be subtracting it. So it will be y equals 500. Find the area. A equals x, y. The value of x is 500 and the value of y is also 500. We will multiply the two. 500 times 500. So the area is A equals 250,000. Therefore, the dimensions of the rectangle are 500 meters by 500 meters to get the maximum area of 250,000 square meters. That's all.
So a manufacturer wants to design an open box having a square base and a surface area of 108 square inches. So what dimensions will produce a box to its maximum volume? So we have first to draw the figure, the box. So we draw a box with a square base. Then we go ahead and draw the sides. From then we try to figure out the x and y, which in this case we prefer x as the side of the base. Technically it's the length and the width, but since it's the same, we can just say it as the side. So y will be the height. Of course, we go ahead and check for the given to identify our constraint. constraint function. So we have a surface area of 108 square inches. So what will be the formula to make up 108 square inches? So to get the surface area, we have to add the areas of all the faces. So since the top is open, we don't need to multiply, we don't need to add that. And we have 5 sides. So we go ahead and add the areas. So first we have the base. Since the base is square, we can say it as x squared since x represents the sides. Then for the other 4 sides, we have x and y. So the height, then the side. So it's x multiplied by y. But since there were 4 of them, we can actually shorten it out to 4xy. But we can go with x squared plus xy plus xy plus xy plus xy until we got it the fourth time. So yeah, but shorten it out, it's x squared plus 4xy equals 108 square inches. Now that we have the constraint, we go for the objective. So we check for the question, what dimensions will produce a box with a maximum volume? So we're looking for the volume. So we don't know the volume, yes. But the formula for the volume in general is length times width times height. So from there, we go ahead and apply it to our problem. So again, we have a square base. So the length and the width will have the same measurement, which in our case, we represent it as x. So we have x squared y equals v. So length times width times height equals volume. So x squared y equals v for our objective function. Now that we have the constraint and the objective, let's go ahead and use the constraint function to get the y in terms of x. So we have the formula x squared plus 4xy equals 108. Then since we gonna use the y, we go ahead and transpose the x squared, so it's gonna be a negative. Then we still have 4x near y, so we cancel. Excuse me. So it will be y equals negative x squared plus 108 over 4x. We can simplify it further by breaking them up, since x squared and x can be cancelled and 108 and 4 can be cancelled. So the equation 1 will be y equals negative x over 4 plus 27 over x. Let's go ahead and substitute the equation 1 to the objective function. So we have the objective function v equals x squared y. Then we replace y with our given. So x squared, quantity, open parenthesis, open parenthesis, negative x over 4 plus 27 over x, Again, let's do it again. X squared, open parenthesis, negative x over 4 plus 27 over x, close parenthesis. So we have to distribute the x squared. Inside the parenthesis, we have negative x cubed over 4 plus 27x, since we cancel the other x from the denominator. After that, we find the derivative.
Find the derivative of volume 1 equals 27 minus 4 d over dx times x cubed minus x cubed d over dx 4 over 4 squared equals 27 minus 4 quantity 3x squared minus x cubed times 0 quantity over 16. Then 27 minus 12x squared over 16 cancel. So volume 1 equals 27 minus 3x squared over 4. Then find y. So y equals minus x over 4 plus 27 over x equals negative 6 over 4 plus 27 over 6. So 18 plus 54 over 12 equals 36 over 12. Then the y is 3. Find x. 0 equals 27 minus 3x squared over 4. So 27 equals 3x squared over 4. 27 times 4 equals 3x squared. Then 108 over 3 equals 3x squared over 3. So cancel. So x squared na lang mabili. So 36 equals x squared. Then the x is 6. Then find the volume. V equals x squared. Then y equals 6 squared times 3 equals 36 times 3. So the volume equals 108. The dimensions will be 6n and 6n and 3n to produce the maximum volume of 100n cubed.
So I hope you have learned something for today, guys, especially in dealing with optimization problems. So you just have to remember that in math, you just need to keep on practicing to master the process, because practice makes perfect. Or in dealing with math, you have to understand and practice in order for you to master the topic or lesson. So that's it. That's it for today, guys. Thank you and God bless.